Well, hi, and thanks for joining me here in my shop this morning while I continue with the process of changing out capacitors. And so I'm going to continue to try to have some kind of test, some kind of qualitative, no, quantitative, as much as I can do it, quantitative test methods here to see the effect of changing out capacitors. In the last video, I set all this up in order to see the effect, and boy, I didn't need any instruments in the end to see the effect of changing one capacitor. It was pretty dramatic. But I think from here on in things are going to be quite subtle in the radio. I think from here what I'm going to do is change capacitors that may have some effect in the tone quality, the not the shape of response in the IF, but maybe there's some response frequency response effects in the audio circuits. I'm not sure. So I'm going to change the capacitors that might be involved with that, and then we'll check and see what the differences are each time, which is a little bit tricky to do. And which capacitor is going to go first? Okay, let me check into that. Okay, so we're still kind of working in the audio area, and we've been fooling around in the tone control zone, volume control zone, kind of in here. I've replaced this capacitor, which caused a huge boost in the volume. This one plays a big role with the tone control, and this one may very well too. See, this is a 0.05, so this guy's a target for changing because it's bound to be a paper wax capacitor. This one, 0.005, this could also be a paper one. So look at this. This is 120 picofarad. This is almost certainly a mica capacitor. So maybe I should look at finding these three. Change out, whoops, I already did that one. This one down here. Change out these three. So this one is passing the signal. Pretty sure the signal's passing pretty good. So this is more of a blocking voltage capacitor issue. Not quite what I'm after right at this moment. This one, obviously it's associated with the tone control, and this one could have some big effect too. Let's go after this one first. C30.05, providing audio grounding on the tab coming off the back of the volume control. And yeah, it's definitely involved in this. Yeah, let's go after this one. C30. Okay, let's see 30. Let's see C30, CC30, 31. Where are you? 50. One of my cats is crying out there in the background again. Snow is falling outside. Winter has come. Cats are disappointed. There it is, C30. With the tone control. From the tone control to a terminal strip. Okay, let's go take a look at that. There. Tone control. Terminal strip in there. Is there a terminal strip in there? You're kidding me, aren't you? So this is the filter capacitor here. Yeah, set is off. Filter capacitor here. Yeah. So these are the 245s up here, the two tube sockets here. Tone control. So here, that's a big 0.05 right there, but it's not going to a terminal strip. There's no terminal strip in here. Is that the guy? So he's coming off a terminal with a resistor that goes over to the volume control. Let's look on the schematic again. So what is this? This is going right around back here. That's all this is doing. So the capacitor, there's no capacitor off this other terminal. So this must be C30. Must be C30. But they've got it tied to ground. They've got it soldered to the... let's take a closer look at the situation here. Okay, that'll be good. So I'll just leave it with the image in the bottom right corner. And we'll go take a look up in here. So there's the capacitor, 0.05, and it's connected to, oh, which terminal is it connected to? I'm sure it's connected where the resistor is. This is not very helpful, is it? It's just like there's a capacitor right down there. Oh boy, where is that going? That's one I'm going to be going after for sure at some point. Wow. That's going to be tricky. Is that the one? I don't think that's the one we're interested in though at all. So the leads aren't going anywhere near here. Right, terminal with a resistor. I forgot to look for that. Terminal with a resistor, okay. Let's just hop over to that. Schematic again. Terminal with a resistor. Capacitor on a terminal. That resistor is hooked up to too. So is there a resistor on? Oh. So see, I think they haven't included this. Why would this run to ground now? That's quite a different arrangement. And then R11 goes over to the volume control back tab. That's the same. That's the way it goes. It just doesn't have this terminal strip. It just comes straight over and ties here. There's no question that C30. What's it doing going to the chassis? Look what this does. This comes back to the control here, to the center. Look here. Control. You see, there's C30 going to ground, and then this is the resistor here going to this back tab. So here it's showing going to ground. C30. And then this is grounded. Oh, this is a ground terminal. Duh, 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 duh. Multiple does here. Okay, so rather than put this, they've saved, we can save 7 cents a radio by just eliminating this. Look, stick this over here, solder this lead to the can of the power supply, of the transformer rather. Oh, I'm too excited. And this guy's got to be grounded. Let's find out how this wire is grounded. Back in the radio. Okay, the lights have come on in my head. There's light coming out of my ears. Just a second here. Just put that backwards. We're going to need it eventually. Yeah, 2:30 in the afternoon now. So we have this one grounded here. Then I can see a bare wire. Well, that's usually the sign that it's heading for a ground terminal, and I can see a bunch of tube terminals tied together. That's another sign that they're actually grounded. And for sure they're grounded. They must be grounded. How grounded are they? How grounded are they? Chassis. Ground. Yeah, for sure. This capacitor. 60 ohms to ground? What's over here? Oh, there's something funny going on here. So on this side of this resistor, which is a brown, black, orange, that's a 10K resistor. And it's going into the volume control. More than 2,000 ohms. But on this side, 60 to the chassis, and all there is to do it is this capacitor. Really? 60 ohms? 60 ohms. Man. That's another good one to pick, I think. Let's get it out of there. Now, just on a very basic sort of view of this, bigger parts probably have a bigger effect on the radio. So I'm going to leave some of the lead here. I don't really want to solder, right onto the can, but I want to leave enough lead I can test it. Not much there. So this is the first one of these molded capacitors we've taken out. Okay, now let me hook up the capacitor here. Hook up the capacitor. Okay, eyes upon the eye. 50 volts. What's it do? Oh my gosh. So again, this is a fairly large capacitor. Oh, wait a minute. Let's try it again. That looks good. You can see the charge up rate, 150. 250 volts. What's the rating on this guy before I 600 volts. Wow, this is testing really, really good. Where'd the 60 ohms come from? The volume control. Oh, for crying out loud. Rec 4, 60 ohms through the tone control itself, depending upon where I had it set. Okay, this gives us a chance though to check these capacitors. As you know, the radio's working. I think we're going to find out these capacitors are in top shape. So let's give this guy the works. We'll take him up to 350. Look at that. So at this point, I really want to measure the value of the capacitance in here in case there's some problem with it. This is actually 0.06. 0.06. Okay, it makes me think I got the wrong capacitor here. Stop thinking. Usually a lot of my problems come from thinking. Okay, this guy be ready to test now. 0.05 should show up on this scale. Now we're watching for where the eye pops open. And there, right there. Okay, it's popping wide open too. Dirt on my own controls here. Good enough. Take a look. So you can see where 0.05 is. This is about 0.06. That's what it says on it. 0.06. So I cut out a perfectly good capacitor. This is really going to make me hesitate now about doing any more of these. Anyway, these molded ones are surprising to me. It is actually surprising. Well, we can't expect this to cause any change in the performance on the machine, on the radio. Okay, let's stick a 0.05 in there. Maybe we'll do another capacitor yet. I'll get that done. Okay, I think I've acquired some company here. Is that you, Peanut? He's just being quiet. So I checked this resistor, it's exactly 10,000 ohms. There we go. Now the other one that might have an influence here would be which one? Let's take a look. My cat, geez, he took off. Well, actually what happened was I tossed the box on the floor. I accidentally tossed it at him. He took off. Hey, I'll do that from now on. If you're bothering me, cat, I'll toss a box at you. So here we go again. So we've done this guy. We gotta find. Oh, this is probably the thing that's buried way deep. 0.005. Okay, I think that's probably what that is. Way up in there. Bring back this little camera. Let's look with the little camera. Well, that's the end of it. Pretty sure I know where the lower lead goes on there. The upper. So what I'll do is I'll nip it down here and yank on the capacitor, and that'll reveal where the upper lead goes. Here. I don't want to ruin the capacitor because I want to test it, so I'm just going to pull kind of lightly on it. It's just pinched up in here. Ooh, I don't like that sound. I don't like those clicky sounds. I'm pretty sure I can see where it's going. Got it right out. Okay, and I'm going to cut that lead, and that lead only. And he just jumped. He jumped out. Let's take a look at it. It's not the best looking capacitor, is it? Looking for the value on it. Point. It says 0.5-1200 volt 14. I think that's just a serial number. There, 005. I can see that. Okay, so this matches with the schematic. Let's give it a test right away. Still have my machine running over here. Okay, we're on the 50 volt leakage test. Yeah, this does not look very good. Let's find out. 50 volts of leakage. 50 volts of leakage testing. Well, it opened up. Let's try 150 volts. Well, it's not opening on 150. So, not terrible, but not like new. This would be the kind of thing I think you could have it in some locations where it would be harmless that it's leaking. Of course, we don't know the actual value of this. When they're leaking, I can't test, I can't read the value of it accurately. So, so that one's got to be replaced. The 0.005. 005. Okay. Great. Now, try to get this in there the same way that one was. Right in close to the ground. Where did it come from? I can only remember one terminal connection. They had a bare lead going up there. Why did they risk a bare lead going up in there? Is everything all tied together? No, it is not. Wow, I really should have used a cover on the one lead there, that's for sure. That's what I'm going to do. And I don't need that much, that's for sure. I'm going to want this to tuck up. Something like this. Just a wee bit too much wire. Shorten that. Shorten that. Okay, up in there you go. Too much cover still. I'm down on my hands and knees doing this, by the way. In case you're wondering why my arms suddenly have a funny angle to them. That's why. So today is a Remembrance Day here in Canada. In the United States, it's Veterans Day. Those are two different things. They aren't the same thing. The Americans generally celebrate veterans of all their wars. Whoops. And in Canada, Remembrance Day is really focused on the First World War. Although it's a little bit generalized and Second World War stuff comes into it. But mostly here it's about the First World War. A lot of Canadians died in the First World War. A lot of people. You know how many people died in the First World War? I think it was 14 million. I think it was the number I heard today. 14 million people? Doesn't sound possible. In the Second World War, I think it was 50 million. 50 million people. Oh my God. So my father was in the Second World War. He landed on DDay with the Canadian Army. The Canadian beach was called Juno Beach. I think the Americans landed 150, and the British and Canadians combined was 170, I think. And that was the fighting force that entered into Europe, of course. The basic battle plan, I don't know how many people know this, because unfortunately, if you watch American movies about the Second World War, you won't know anything about what really happened. I'm sorry to say that. It's really quite made up, American war movies. The basic battle plan was the British and Canadians would get on their beaches and then head for a big city called Caen. And the Germans were holed up in Caen. It was one of their central areas. So if the Canadians and British could attack them there, it would force the Germans to commit large forces to defending that area. They had to defend that city. It was important to them. Meanwhile, the Americans would do an end around. They would avoid Caen and come up more interior in France, past Caen and a large portion of the German army tied up there, and then press forward towards Germany. And then, theoretically, hopefully the British and Canadians would secure Caen and then also move forward, and then all three armies could head for Germany. That was a basic theory. The problem is Caen, they couldn't get to Caen in one day. The Americans got hung up on one of their beaches, something horrible. Of course, things don't work out the way they're planned. And I'm just checking to see if I can solder that connection up there. I don't think it's squeezed enough. The Germans had a chance to reinforce their Caen position and other positions because the D-Day didn't advance as far as expected. Actually, there was only a couple of small soldier groups that actually made it to their D-Day objectives. Out of those 300 and something thousand men, only a handful made it to their real objectives. My dad was one of those people. My dad landed on the beach in Normandy, Juno Beach, with 400 other Canadians in the very first 10 or 11 boats. Really having a hard time squeezing that. Maybe just do it right over top of this. So I've talked about this before in some of my videos, but it is Remembrance Day. I always had this vision of my dad with 150,000 soldiers around him. I mean, this huge, massive male humanity running across the beach, like sometimes it's portrayed in the movies. The reality is the whole thing's a lot lonelier than that. You picture my dad in his boat with his 40 guys and 10 other boats. And each boat is a football field apart. You can hardly really see the other boat. So you come off your boat with your 40 guys, you're all alone on that beach, the 40 of you. My dad probably wouldn't be here, and therefore I wouldn't be here if it wasn't for the fact that his boat had drifted about 100 meters or something like that to the right. All of them did. So another boat drifted over to the right, and then they landed on the beach. My dad and all the people on his boat pretty much made it right across the beach. They were successful. I don't really know if any of them got killed crossing the beach. Probably a few. People in this boat, virtually all of them died on the beach. Why? A machine gunner located right there. So who's the machine gunner going to shoot? Who would you shoot if you were a machine gunner? You got guys running. Some of them are running right at you. You're going to shoot at the guys who are running at you. You won't shoot at these guys. So that's why my dad made it across. Made it across the beach. I think it was a huge beach because they landed at low tide. Another thing they were sure would fool the Germans, because who's crazy enough to land at low tide and then have half a kilometer of beach to run across? That's what they ran across. Half a kilometer. Oh man. And we all know how that ended up in the end, don't we? So my dad carried on in the Second World War, fighting in Europe for a year. He's one of the longest fighting Canadian soldiers. Not recognized as such. Nobody knows that. Lots of soldiers fought that kind of length of time, but he was among them. He came back thoroughly messed up. A thoroughly messed up human being. Terrible thing. Terrible thing. In my view, my opinion, terrible thing to train people for war, train men and women for war, train them to be killers, train them to train out their humanity, get rid of it so they'll kill cold-blooded at the command of some political boss. Not just a horrible thing to do to people. But then again, I'm very proud of my dad. I don't know. Does anybody doubt fighting the Nazis was fighting evil? Anybody doubt that? So my dad was part of Antifa. That's right. Anti-fascist. Could say a lot more at this point, but I'm going to stop talking about that stuff and get back to this.
it goes. I think I got that. Looks good. Now, just pop that down like that. Swing it around and try to remember which terminal it was. Which terminal did it which terminal did it come from? Okay, I'll make this last connection here. So it turns out the capacitor I just replaced is not really the one I was targeting. That's okay. This is running between the plate and the cathode on the output tube, one of them. The other output tube has exactly the same capacitor. It's right there. That brown guy. So I'm going after that one too. And then the other capacitor, I don't know, I'm going to have to look at the schematic again and figure out what I was thinking. Because well, this one's just as bad for getting at. I have this big bundle of wire here. I don't want to mess around with that too much. This is probably the Magic Eye wire bundle coming in. And so we're all stiff. I can't really move any of these wires. Got this here. Try to leave enough lead. Oops. And I'll pull it out. Oh, it's fairly easy to get at. Oh no, it isn't. Take that back. Right in here. Oh boy. It's running between plate and cathode. It's got full V plus across it. It means you want this to be in good shape. This doesn't look the same as the other one. Let's take a closer look. This doesn't look like the other one at all, does it? Let me get the other one. So here's the other one. Oh yeah, same size, same physical size. What can we see on it here? That looks like it just has the serial information. I don't think there's any question it came from the same pins. There's no other capacitor in there. That's got to be it. That's got to be it. They look the same. Very good. Well, I got a tough spot here to hook up this next capacitor up in behind the control here. Put a hook on the wire. Oh man. So one option in doing something like this, you remove the thing that's in the way. Or trying to move this, and I'm just introducing a lot more work. Better that I just fiddle my way through this situation. Get the soldering iron up in there. Wow. Let's see if I can do this. Now I know you can't, well you can almost see the connection, but I'm way down here on the floor. Oh wow. I think the solder is going to hit the soldering iron. Just a second. That would be my wife. There we go. Good. Okay. Okay, so I've done that second capacitor. Just check it, make sure. Yeah, looks good. Now the capacitor I was really after, though, is located down here. So what they've done is, I'm looking for this capacitor up in this area because it's associated with the tone control, but they've just brought a wire, this green wire here, down to a spare terminal on this tube just to add some confusion, and then run the capacitor down to here. This is going to be a grounded terminal, I bet. Just trying to verify that. No, it's not grounded. That's right, I remember looking at the schematic now. This doesn't go to ground, it goes further into a circuit. But anyway, I just got to replace this guy here. Let's do that. .05, that's what I'm looking for. Made in the USA. New York, New York, New York. If I said Chicago 60609, that would mean something to many of you who are my age. Okay. .50 volts. $150 volts. 250 volts. See, this is why this radio was working. Most of these capacitors are good. So 0.005, let's measure his capacitance here. 0.005 would be on this scale. Here we go. Make sure can you see the eye? Oop, there it goes. Right in there. Where did this end up? If we look right under the pointer, we see the number 0.005. Look at that. It's like dead on. It's absolutely exact. It's better than the new ones. So, again, you know, when you do this kind of stuff, you don't really know for sure the condition until you take it out and test it. 005 again. Another 005. Okay, so I'm going to work this guy in. I go all the way up there. What if I skip this? Just go all the way. I gotta get all the way down to here though. Can't go all the way. That's the problem they had too. Couldn't go all the way. way. Now the other end. So the green wire I'm working around is like almost every green wire I see in a radio. It's gone, the insulation is particularly bad on green wires. I don't know why, but it must have been something about the green dye that was used. Okay, so I think what I've done today is deal with every capacitor that could influence the tonal quality of this radio. So what's left to be done now is repeat that test. Make sure this isn't shorting here. That's good. Repeat some of those tests and see if the frequency range of the radio has improved. So to do that, let's see, we still have everything running. I think I've got everything running. Just the scope. Fire up this radio here and we'll warm up for a moment. Yeah, that's right, we need to disconnect it too. This was watching the, oh, where did I have this connected? Not coming to mind. Let's get the radio going. Okay, I've done a number of capacitors, so we do want to be watching those dim lights. Am I blind? Nothing happened at all. Oh, there's power in here. Oh, they're there. Just took a long time. That's a good sign in a way. It sort of indicates the filter capacitors are holding charge for a long period of time. Seems pretty nice to me. Let's do our test now. Somewhere around here, wasn't it? Full strength on that guy. 1 million, except for 1,000,000 hertz. I think that's it right there. Okay, so what I'll do is I'll reduce the frequency of the. We're not sweeping. We're sending in a high frequency of 7
kilocycle. Let's take it down. You can hear it. We're at 3 kilocycles now. Still starting to hear the volume level go up and down as I tune across it. Now there could be other things causing that. So we'll take it up to 4 and see what happens there. 4 kilocycles. Come across. Hear it? Gone. Hear it a bit. So the response on this radio is consistently like this. Use my marker. This is what it sounds like to my ear anyway. Instead of being a nice shape like that, something like that, instead it looks like this, I think. It's not drawn very good. But the idea being that this is steeper than this. I don't know, something like that. And that could be because of other tuning issues in the radio. So let's see how high we can hear this. In fact, I'm going to go full power. And we're going to go up to 5. This is 5 kilohertz. Gone in the middle, there at the side slightly lower. So I would say if were receiving an AM radio station and there was 5 kilohertz sound there, and you had this radio tuned in perfectly, you probably wouldn't hear any of it. You would hear that much of it right there. Another dirty control to clean. Hey, how about higher? Let's go higher. 6. You hear that? Well, I hear something, you know. Barely hear it here. It's a longer gap now to get all the way to the other side band. Right? Fortunately, this is all messed up. So really what I'm doing now, just going back to this kind of diagram, let's try here. What I believe is happening to the radio. Nothing bad. So you have the center carry, you have the 2 side bands. We're at 6 kilohertz. So the distance between this frequency, which might be 1021 kilohertz, and the distance over here is just 5 kilohertz tone. 6 kilohertz, make it 6. Okay, so the tuning of the radio, you tune it right in the middle. Right there. I don't hear either of these. The tuning of the radio is something like this. It doesn't mean these are absolutely unhearable. I mean, you have to crank the volume up until this line comes up above here and you start hearing it. Something like that. You can think of it that way. There's something called the 3 dB point across here. People usually use this as the actual bandwidth from the 3 dB down from here to there. But there's a lot more than 3 decibels down. You can barely hear a 3 decibel change, which is why this is desirable. So either this radio cannot receive this high frequency, or other adjustments have to be made somewhere in the radio to broaden this guy out, to change it from such a sharp peak, because I've got it tuned pretty sharp, to a broader peak like that. And the risk, of course, being that if this gets too broad, then you start picking up the next signal from over here. You pick up the next station. Okay, but as for this little effort here, replacing a few more capacitors, and I'm not sure this made the front audio circuits work any better than the last couple here, but it certainly didn't make them work worse. The tone is very nice now. I like the way it works. Did I do all that with the tone turned down? Maybe I did. Doesn't matter. You still hear the same situation. Down, then back up. So I think probably we can go higher on this now. Let's do that. Let's go higher. This is 7 kilohertz. I hear it on that side. Or here again, I hear something. The reason I'm not declaring it to be 7 just running into a little bit of interference here. Let's go a little higher on the transmit frequency. Hear it? Gone. Hear it? Huh. Can hear 7. Let's go for 8. 8 kilohertz. Turned it up a bit. Okay, we're going to listen to this tone now. I'm going to change the frequency on it and make sure this is really, is this really 8? 7? 6? 5? 4? Oh my gosh, that's 10. I can hear it. Frequency response in the radio's potentially great. No, speakers and all that stuff. Tubes, everything. Excellent. So when it comes time to do the final alignment, we'll see if we can't broaden this out, get the right shape in the IF curve to really capture the potential fidelity that this radio can do. And what are we discovering? We have some capacitors that are absolutely shot and others that seem to work just like new. So we're going to have to continue just plodding our way through them. And great. Okay. That's a lot of time spent in here today. So on to other things. Oh my gosh, it's 4 o'clock in the afternoon. Yikes. Thanks so much for watching, and see you on the next video.